Hey friends, it's time to get some updates about the latest innovations in Azure Data Factory. Hyong is here and he brought along a few friends from the team to show me what's new. We're going to learn about Azure Purview integration, new data flows functionality, and CI/CD for Data Factory pipelines today on Azure Friday. Hey friends, I'm Scott Hanselman and it's Azure Friday. I'm here with Hyong. How are you?
I'm good. I'm good, Scott.
So you've put together a whole parade of friends who are going to talk about all kinds of new updates to Azure Data Factory, and you've brought them from all over the world.
That's right. Yeah. So Data Factory, as you know, like many of you already know, right, is continuously innovating, whether it's integration with Purview, whether it's some of the improvements in data flows, or even making sure that data ops is the best experience. We invited friends all over the world just to come to this show to show you some of the latest and greatest.
That's great. What kind of things are people using Azure Data Factory for? I'm always impressed with the amount of data that's being pushed around. We're talking about huge amounts of data that's being chewed on every day, all day.
That's right. So Data Factory, in fact, as a fun fact, right, move about petabytes of data every single month globally, which is just like mind-boggling. But I think one of the things that people use Data Factory for is for modern data warehousing scenarios, right, where you land data into the lake. But more importantly, after you land data from all these different sources, and it can be on-premises, it can be multi-cloud, it can be data sources that's on Azure. Once it's in the lake, you want to be able to transform them to get them into the right shape before you land them in your target data store, right? And the target data store could be Azure Synapse Analytics using SQL pools. It could be landing data in Azure SQL, and so on and so forth. And I think one of the key thing about Data Factory is really the notion that you could do it code free, but more importantly, we own and spin up the managed infrastructure to do it at amazing scale. And so that's essentially what Data Factory is used for.
That makes me wonder how anyone ever did it before.
Yeah, I used to be from the exercise team years ago. You'll run it on a single machine. If it's not enough, you will want to scale up the machine to be able to deal with the load. Today, this is all done in the cloud in a serverless manner, right?
And there's been a lot of talk lately about Azure Purview and how it relates to Azure Data Factory, and we're going to hear about that today as well, right?
That's right. Yeah, that notion of data integration and data governance all coming together, right? One, of course, to get tremendous insight into not just your data integration pipelines, lineage, if you will, but more importantly, for you to be able to troubleshoot when things goes wrong. And we're going to see some exciting demos on it today.
All right. Who is our first friend?
Yeah, so today we're going to bring on Linda. Linda is going to show us all the exciting things around data integration and data governance. And to you, Linda.
Yeah, thanks for having me here, Scott, and thanks for the introduction. So today I'd like to demo some cool features and really to showcase it how Azure Data Factory and Azure Purview integrate together so as to bring the data integration along with the data governance to enable organizations to really derive tremendous insights into the data lineage, data map, data discovery, and more in the future as well. So I will start with this data factory view. So the ETL flow usually start with the data ingestion that customer bring data from various sources into the lake and do the transformation next. So here is one of the demo factories. And when we go to the management hub, that you will see that there's an Azure Purview entry here. This is the way that customer can integrate or connect the data factory with the Purview account. So here we have the Purview account connected, and actually when do the connection, customer can browse from the subscription to see all the available Purview accounts there. So I already have that connected. Then we go to the pipeline and to build a pipeline to ingest the data. So in this example, I bring data from various tables from a SQL Server into a data lake. In this example, I first do a lookup to retrieve the table list that I'd like to ingest, then pass to the next for each activity. Inside of for each, we will do a copy data to bring the data from the source SQL Server and into the sink as a Parquet data set. When we run this pipeline, this is the monitoring view. I already run that. So you will see that this is all the data copy activities executed. Each copy activity actually bring data from the source table and to a corresponding destination in the data lake. Well, with this activity got wrong, we can switch to the connected preview account to see what happens in that preview account to generate the data lineage insights there. This is the connected preview account with the factory. We can search the data factory name or search the data assets. Both will bring you to the insights view. I will just search the data factory name here. Then we will see that this is the data factory that happens to push the lineage from the factory to this preview account. I can click into this assets and see under this factory, I have the pipelines that generates the lineage. And this is the copy activity I just run from the factory. And on the lineage tab, we can then see the data lineage. So we can see here that we bring data from different SQL tables into the different destinations in the ADL's Gen 2 accounts with each of the individual paths with the mapping. And we can also see more on what not shown in this default view. There are many more tables actually got moved during this data ingestion process. For each of them, we can see the mapping from the original source to the destination as well. And from there, we also have the options to open that in the data factory to see more details. So what happens under the cover is during the activity execution, we actually capture all the data lineage from the source to the sink and report that to the connected preview account. So in addition to the single factory, there are also quite a common requirements that customer would have different data factories connected there, running different ETL or ELT process that touching different data assets. So we can actually connect multiple data factories into the single preview account so as to generate a holistic view across all the data assets in the customer's organizations. So to continue this ETL flow, I actually have another data factory doing the data analysis. So after the data ingestion, to bring data from various sources into the lake and populate that data lake, I can do deeper transformations and analysis based on the data from the lake. So in this factory, I also connect it with the preview, and in this case, it's the same preview account. And in this factory, let's do a data flow to do the transformations. So if I switch to the pipeline, you will see that there's a data flow to do the transformation, and click into that. This is basically do some simple one to do some joins and derive columns to generate aggregated view based on the source columns and write data to a single sink SQL table. Once this is executed, let's continue to see what customer can see from the preview account. So in this case, let's instead of searching the factories, let's search for the detailed the data assets that got touched. In this case, let's search the sink table that we write the data into. In this case, it's the customer orders. So we can see that there's a SQL table that is the destination. We write the data into that. So if we switch to the lineage view, in this case, we can actually see the holistic view from the original source that is the SQL table. We bring the data through the copy activity, then into the data lake. And after the data landed in the lake, we do a data flow to transform the data. So we can see that the data flow is from the factory data analysis, while the copy activity is actually from the data ingestion. So this is really bring an end-to-end data lineage view to the customer. In addition to that, we also have the column level lineage. For example, for this sink table, we can see that there are multiple columns. Once we select the column, we can see that where does the data originally from. In this case, we can see it is from this SQL order header table. Well, if we select the other column, this is from the other table. So with that column level lineage information, that can help customer to do from the upper level we can see that if some transformation or data ingestion failed in between, you will see a red flag there. So to showcase you that upstream have some issue and cause the downstream data may not be the latest, then that can help you troubleshoot and identify the issue as well. And also from the upstream, when you want to change some data, for example, I want to update this subtotal column, then we can know that which downstream table or downstream data will be impacted. And those such a subsequent downstream impact analysis will help customer identify the potential issue and before really touch the source data. So in addition to that, this is like how Azure Data Factory can report all the data lineage info from the factory to the Purview account so as to generate this kind of lineage view and also help customer really discover all the data got moved and transformed during the ETL process to draw the data map into the Purview. While on the other case, we also enabled inside Data Factory, we can search the assets from the Purview. In this case, as the factory is connected to the Purview, let's just search to discover what data assets is available there. For example, we search the customer, and you can see this view is actually the similar as the search experience in the Purview. What happens is ADF will retrieve the assets from the Purview and populate that directly in the Azure Data Factory UI. So customer can directly discover those data assets and further use them to build the ETL and ELT data, the flows. So in this case, we can see there are a bunch of results got returned related to the customer. And we see there's a customer updated CSV, which seems interesting. If we click into that, we can see that this assets has some of the classification informations, and we can see the properties and also the data schema of this data assets. So if we want to use this data to build the ETL flow, we can click some gestures here. You can new a link service or new data set, new data flow. So let's new a data set. In this case, all those informations will be pre-populated based on the search result from the Purview. In this case, we know that this is I already have a link service created for that. Then we can continue from there to really generate a data set. Then all the fields is populated based on the Purview results. Then we can continue to preview the data and also to use that in the ETL flow. So with this capabilities that we really bring data integration and data governance together based on the Azure Data Factory and Azure Purview integration. This is the capabilities that we enabled at the moment. And going forward, we're looking forward to further enhance this both lineage and data discovery, all those experience and moreover to add the data governance tiers into the ETL flows so customer can really generate more insights based on this integration. So stay tuned on the upcoming exciting features. We'd like to keep all posted for the futures.
That's really cool. It's amazing to me that you can work on so much data and you're just in a browser. I know that we can do anything in a browser now, but I'm impressed with a couple of things and I'm curious. I'm not seeing any SQL or transformation languages. There's nothing in text. It's all really being done in a user interface. Is there no standard obscure language like SQL that people use to move data from place to place? Is there text behind these user interfaces?
Yeah, so Azure Data Factory provides the GUID for customer to really easily use the drag and drop ways to build the ETL flow, and all those can be easily configured on the UI without customer really touching complex codes.
That's so cool. It's amazing what you can do and pushing so much data around entirely here. And then you can save them as templates, share them with your coworkers. And now you're plugging in and playing here with your blocks. And those templates can be shared with the entire organization.
Exactly.
That's so cool. I'm always impressed. The user interface is just so polished and so powerful. The idea that you could push petabytes around from your browser is hugely helpful. And comparing it to what Wei Hyong said at the beginning, how we used to do it on a machine, and that machine didn't do enough work, get another machine. The power of the cloud has completely changed how we push data around in just a few years.
Absolutely. So Azure Data Factory is a fully managed serverless, highly elastic service to really empower customers to do the data ingestion, data transformations at scale. And with this UI, easy experience, customer can really just build up this kind of flows just in minutes, then to move the handle the data at scale.
Fantastic. That is a wonderful demo. Thank you so much, Linda, for your time.
Thank you.
Thank you, Linda.
Thanks for having me here.
All right, that's cool stuff. All right, so now we understand how Azure Data Factory can move things through Azure Purview. We can understand the lineage and where our data is going and where it lives and where it started, and all that ETL lineage is being captured entirely in Purview.
Yeah, that's right.
Yeah, please.
Yeah. Go ahead. Yeah. So
well, now I'm wondering how data flows. I'm trying to understand some of the sources of where that data flows, and maybe more complicated data types as well.
That's right. And you saw that, like Linda showed a glimpse of data flow. And in previous episodes, we did show data flows as well. Mm-hmm. Data flow continue to innovate. And one of the top asks for customers was that, in order for you to describe your transformation, you do it in this GUI interface. But then we do it at scale. But then one of the things that people often ask about is, the cluster that is used for processing all these data flows takes several minutes to spin up, right? And today, one thing that's really exciting is we're going to show you how we get from minutes to seconds, which is just like amazing. And for that, I'm going to bring Mark Kromer. Mark Kromer leads the Azure Data Factory data flow efforts to show you some of this exciting work that's happening.
Yeah, thanks, Scott. Thanks, Wei Hyong. So what I wanted to talk to you about today, let me go over here, is a little bit of a deep dive into some of the things that you were just seeing from the previous demo where Linda walked you through what we're doing with integration into Azure Purview, which is, of course, like critically and vitally important to ETL and into Data Factory. Anytime that you're working as a data engineer and you're working with ETL and you're able to combine the metadata across your data assets into a single view and able to integrate that with Data Factory is a great advance, something we've been working on for a long time. And one of the things that that Linda was showing you and demoing for you just previously was how you would bring together those pipelines in the ETL process, including the data transformation piece within your single factory. And like Scott was saying, the power of that sort of low code, no code environments within the browser is something that we spend a lot of time, a lot of investment in the Data Factory team. So like Wei Hyong was saying, is that when you're transforming that data in those massive amounts, you require a very powerful processing platform to be able to transform data, especially data with complex types. So because Data Factory is a cloud-based service, and because we have that sort of power and we bring it to you at your fingertips without needing to provision servers, I believe Linda was talking a little bit about the serverless nature of Data Factory, which is absolutely what we are key upon bringing to market here. One of the things that we do in the transformation piece, which is known as data flow, is give you the design interface, the design environment that is low code, no code, and to be able to bring that to you in that serverless manner without you needing to stand up a Spark environment or a big data environment. We give this to you through what's known as the Azure Integration Runtime. So let me actually show you a quick example of what I'm talking about. So specifically to what Wei Hyong was mentioning in terms of making this environment super snappy and fast and responsive to you and your business, what we've done is we've enabled a way for you to serverlessly stand up a compute environment that's completely ephemeral. It comes up and goes down as your jobs are executed within the cloud, within factories in ADF. So on the screen, I have an example of a very, very simple pipeline that is just executing two different sets of operations, and they're both data flows. And the first thing I'm doing is I'm making files, and I'll show you the detail of this in just a minute. But keep this in mind is that what this is doing is this is going to process large amounts of data coming from Azure SQL database. The table I'm pointing to is the products table for AdventureWorks. So we're talking about bikes here. And then the next thing that process does is that turns those rows and those columns into Parquet files with arrays, map data types, structures, right? Very complex data types. And what happens is, what we've seen in practice from our customers, and one of the things that we focus on very, very strongly within our team is we focus very much on reacting to customer voice in the community within Data Factory. And what we found is that within Azure All Up, of course, is that the data lake environment is key to your success. So because that's the case, what you're going to end up with is a lot of data that is of that complex type. The days of everything being into easy to manage SQL tables is a little bit in the past. And so what we found is that when you're performing these kind of ETL processes, you need to have a way to easily work with some complex JSONs and Avros and Parquet. And so we've built that into the data flow piece, and some of the new features that have surfaced are very, very key to make that very easy. Now, in this case, I have these couple of things that are making those complex types from a simple type like a table, and then I'm going to do some things with those data types. I'm going to be able to expand upon them. I'm going to be able to compress them, and then at the end of the day, I'm going to put them into a special form of Parquet files in a special place within my data lake, within the Azure Data Lake service. Storage, and that storage is going to then store that data as Delta Lake format. And the Delta Lake format will allow me to then update, insert, have what's known as time travel across those, so you keep versions of those rows live in your data lake. And you're going to do that without needing to understand any of this. So that's the key to this, is that's that serverless nature in the low code is just build your logic, build your intent graphically within these graphs that you see on my screen, and Data Factory will handle the rest. Now, to make this happen in a way that is going to meet your SLAs for your business, we've done a very important thing. So let me get to what I was just talking about earlier, as I actually want to show you, which is the integration runtime. The Azure integration runtime is the serverless part of Data Factory that allows you to execute these powerful features on a serverless set of compute. So you see that on my integration runtime, I called it Data Flow IR with reuse. That's just my kind of cryptic way of naming things, but let me show you what that actually means. I'm going to go into the Manage portal on my Data Factory UI, and in here we're going to find that Data Flow IR under integration runtimes. So we call them IRs all the time, so you hear us kind of abbreviate it as IR, and it is this right here. Instead of actually showing you this one, let me actually do this. Let me show you something. When you create your integration runtime, this is probably a better way to explain to you what's going to happen, is that you're going to be able to go down here under Data Flow Runtime, and you'll be able to just check a box. It's called Quick Reuse. This is in public preview. This is a very recent innovation from the Data Factory team. Invention is actually a good word too, that we've brought to market that will allow you to take that compute environment and able to have it be available to you within seconds. So when you click this box, you're able to have a very powerful Spark environment to execute your data flows at scale very, very quickly. And it's associated with this time to live. So I can say, after my job is completed, leave that compute environment around for a few minutes so that I can run more jobs against it. And we're able to we're essentially able to reuse that compute environment. While I'm here, I do want to also show you another very important recent innovation that we've brought to market around the Azure Integration Runtime, is also the VNet capability. So again, these are all things that are in direct response to what our customers are asking us for. Now, what that actually means, that's a lot of techno babble, and what does it actually mean? What does it actually, how does it impact what you do within your data factories? So if I go over to the monitor view, I can show you a recent run execution that I had of my loans demo. So this pipeline over here called loans pipeline is executing some fairly large mocked up loans data. And this has two data flows in it. And what you see is the time to execute these was about 5 minutes. In that period of time, that is all pure computation. So if I look at the details of this, you'll see that what happens is each of the parts of the logic within my complex data transformations are all transforming and writing the data. The time it took for me to get accessible to me as a customer, as a user, to get accessible to me a powerful Spark compute was 2 seconds. So previously, it would take you in a matter of minutes to be able to acquire and provision a Spark environment. I now have that environment available to me in 2 seconds. So now you're spending all of your time and your concern simply on the data engineering piece of things, the logical intents of what you want to do with your data. Don't worry about all of the nuances of clusters and of Spark and all those things. We handle all that for you and very, very quickly. So that's the quick access for the serverless compute. A couple of just 2 or 3 real quick things I also want to talk about in terms of new innovations within data flows, in particular that we've done with Data Factory. Let me go back to a larger example of a pipeline that's a little bit more of a canonical example of what you might see within pipelines in practice. So what I'm doing in this data factory is I'm ingesting some data into the lake. So this data is most likely going to be coming from on-prem or another location or even another cloud for that matter. So you'll see that this is a very common sort of stepwise approach to transforming data in the cloud, making it available for your business. I'm ingesting that data, and then I'm using the Power Query activity, which is an update to a public preview and another new set of innovation that we have within ADF. The Power Query is doing some data prep and data wrangling to clean some names and some values in there. And then I use the data flow to dedupe. Now, both the Power Query and the data flow use that same Azure integration runtime Spark environment. So we're able to take your Power Query, we're able to execute that using Spark, and then we take your data flow, and we're able to then perform additional transformation on it. So whatever environment you're comfortable with, if you are comfortable in the design, the intents of your data from a graph design. So in terms of working with data and transforming the data, do you prefer to work with a toolbox of steps that you want to use to transform your data? You'll see some things in here like the ability to parse complex data types. You can derive columns, aggregate data. Or if you prefer that sort of data first approach, the Excel spreadsheet style approach, we've incorporated the Power Query capability within Data Factory as well. So if I go back to that data cleansing pipeline, and you see the Power Query activity right here, you're able to use the Power Query embedded environments to work with your data and to transform it using the data first approach. So it's kind of the data transformation at scale serverless, choosing if you want to have data first or if you want to have essentially design graph first. Both of those are low code, no code environments, but they both give you that same end result of being able to execute these at scale. And then the last thing that I just wanted to quick touch on is if I go back to my pipeline, my data cleansing, I'm using Dataflow to dedupe that. And so activities or actions like deduping, working with complex data, that's all when you're going to go into Dataflow and use those powerful tools within there. And in fact, in my dedupe example, all I have to do is just have a single aggregate transformation to create distinct rows. Now I'm taking my data in my lake, I'm taking out my duplicates, I'm bringing in just the distinct rows. And then I can do something like this. I can go over here to a data flow that's called my complex data types, and I can put that data into Delta Lake. And then Delta Lake will be able to do things like take my the data coming from my SQL server, my SQL database, which is the bike products, and is able to do things like turn those into some map data types, create structures of that data, and then store it in the lake using the Delta format. So that's a lot of new innovations coming to Data Factory through data flows that are the the data transformation at scale piece. And now with the reuse capability on the Azure Integration Runtime, you'll see that this environment for you is very, very fast and very accessible. And with that, I'm going to, that's pretty much it for the data flow section. I believe that we'll go back to Scott and Weihong, and then I believe Abhishek's got some other, some CI/CD things for you as well. So thanks.
Thanks, sir. One of the things that was said that was new to me and may be new to some of our customers who are watching the show who are somewhat familiar with data flows but haven't heard all of the different words and acronyms and things like that is that notion of Parquet, which a lot of people are still pushing CSV files around. And that's an innovation in the open source space that is being used here as well to take things by an order of magnitude down in both size and in processing. So that plus the delta, you call them delta flows?
Yeah,
Delta?
absolutely. Yeah. So what happens is that's right. The Parquet file formats is by far with our data transformation customers the most popular format in the lake. It compresses very well. It's columnar, so it gives you that very, very fast ability to do ETL and to be able to analyze data in that format. And then what happens is you can compress that down into very compressed files. And so we have it all built into Data Factory. So when you load that data into your lake, you can either have it as, in this case, this is just a simple sort of Parquet sync. When you take that and you use the Delta Lake format of that, then that even gives you a lot more control. That gives you sort of CRUD operations on those files. Because one of the sort of frustrations that a lot of folks who are new to data engineering in the cloud and in the lake notice is that when you're working with data files like Parquet in the lake, you commonly want to do things like slowly changing dimensions and be able to update and delete rows. That's when you'll use something like Delta Lake. Delta Lake will give you that ability to then take those files stored in a Parquet format, which is compressed and very fast to access, and then be able to get those sort of ACID kind of CRUD operations on that on the data. That's what Delta brings to it then.
Cool. Building on all of these different innovations, both in the open source space and the Azure cloud to make things just faster and easier, going from hours to minutes to seconds.
That's right.
Fantastic. Thank you so much for your time.
Yep. Welcome.
Thank you, Mark.
All right. Last but not least, what's our finale?
Yeah, so the finale is really some of the improvements that we did around CI/CD. And as you know, right, CI/CD is top of mind for many, many people and many, many organizations. And Data Factory, of course, participate as part of data ops. And you want to make sure that, whether you're designing all this pipeline using the beautiful GUI environment, but you want to make sure that once that is done in a dev environment, you could leverage your release pipelines to push this to either staging or production environment. And so we're going to bring in Abhishek Narain, who's going to share with us some of the exciting things that's been happening for ADF CI/CD.
Hi, guys.
Hello, sir.
Great. So I'm going to run through some of the new changes that we did in the release pipelines with respect to Data Factory and the CI/CD changes as well. So before we get started, just a quick recap of the functionalities that it adds in terms of data engineers. So one of the thing is collaborations, especially when you're working in larger teams. It does help a lot having your work backed up by Git. And the second part is saving your incomplete work. What we see is data engineers, when they start building pipelines, these pipelines might be extremely complex in nature, which might take days to weeks to build. And so in the meantime, they might want to save their work. And so Git works out really well over there. And then we have also seen Git also helps improve the UI performance because especially when you're working with a lot of artifacts in Data Factory, the UI, we are able to get like 10 times better performance while using Git so that you can load only specific piece of code that you're doing in your branch rather than loading the whole artifact set. So these are key advantages that as data engineers get using the CI/CD piece. Now, the improvements that we have done is the current flow that you see on the screen, which I've shared. This is the current flow. And in the current flow, we got some feedback around automation requirements. Currently, it was when people's data engineers start authoring their code in visual fashion in their collaboration branches, and then they require to click a publish in the UI to be able to generate the ARM templates out of it, which then goes and gets deployed into different environments using the DevOps release pipelines. Now, what we did is we actually created a new Git package, which helps you actually release pipeline itself can validate and generate the ARM templates and then deploy it across factories, which means this particular manual step is no more required. And so here's the new flow, which we will basically demo today. In this flow, there is a ADF created npm NuGet package, which we'll use, which will basically help us generate the build from the dev factory. And then the build artifacts will be used in the release definitions and release pipelines to kind of release it to any environment, including your dev environments. So you can actually do a automatic CI deployment in your dev environments as well. So it's completely automated. This is what customers been asking. So here's the change that we did. Now I'm going to quickly run through an example. This is where you get started with. You can start with Data Factory, Manage Hub, Git configuration, click on config. It's pretty simple. In this example, we will use Azure DevOps. And I have a Conteso enterprise account. There you go. And we'll use this project. We can use an existing one as well. Let's use this data engineering project. Let's use the main branch as the collaboration branch, where we will be using that particular branch to publish changes or generate artifacts, build artifacts from this particular branch. And this is just for backward compatibility. We still kept the backward flow, which basically required a special branch, ADF_publish, where we generated the ARM templates, but this is no more necessary, especially when you're using the NuGet package to kind of point out to any particular branch and deploy the code from there. So I'm going to import the resources, existing resources into the repository as well. And this is how simply you can connect the source control to your data factory, which means that all the artifacts or all the visual design that you do in terms of the data flows, which Mark showed earlier, or in terms of pipelines that you build, which Linda showed in terms of the copy pipelines, everything will be stored in your Git by just a few simple clicks here. And once it's done, we have configured the source control part of it. You would see if you go back into your code repository, I'm going to use the same code repository and quickly check out the files. You can actually see the branch that we used, the project that we used, and you can see all the artifacts already being available over here just now. Now, the next step is how do I do continuous integration and deploy it across different environments using the release pipelines and release and using the new NuGet package that we created. It's right there. So let's go ahead and build that release process. We'll go to the pipelines, create a new pipeline. This is Azure, and this was the repository. And before we actually do this step, we will require to store package.json, which basically defines a version of the npm package. So I just missed to do that, but I'm going to quickly do that. I'm just going to go back to the repo, quickly create a new file here, and call this as package.json. And we will quickly define our package information over here. This is the dependency. And while we do the build, we will use Node. And this is the library that we are referencing. And here's the version dependency of that library. The 1.5 is the latest version. Just going to quickly commit that. And we are good. So this basically defines the utility and the version of it. And now we go back to the release pipeline, set up a new YAML definition. And I already have a predefined YAML. By the way, this YAML can easily be found out in our documentation. It's right over here. And you can find each of these steps here. Just need to modify the specific data factory instance, which would be used. The dev data factory instance, the resource ID of that needs to be substituted here. And then it's all ready to go. So I've already done that for my particular dev factory. And we are good to go. I'm just going to do this, save and run. And it's going to trigger the changes as well. And a little bit It's going to take a few seconds. It's queued and it's going to execute. In the meantime, what we can do is, this is how we generate the build artifacts, and we have specified the master branch where we were actually generating the build artifact. It's being generated right now. I can quickly show you. This is where we specify, we're going to pick up the changes from the main branch. That's going to be the trigger for this particular build. So you can specify now any specific branch as well. So it gives you limitless possibilities. You can actually use any other branch. Especially, we heard this feedback from customers where they are doing QA testing, and before they do actually emerge into the main, they might want to test their own branch separately as well in a QA factory. And now you can achieve that because you can specify different triggers, and even if it's your feature branch you're working on, you can actually use that for building the package and then deploying it into your QA factory and testing it out. Now, setting up the release pipelines. What we have done now is we have set up the build process. Now we're going to quickly create a release as well. I'm going to add an artifact here. And we'll put a branch filter, which will trigger the build. And this is where we get started with. I can say this is my dev, where I will deploy to, yet all the code might not be deployed to dev. So this is where we can deploy this to dev and set up a quick task. Now, this is another improvement that we did. Earlier, there were 3 steps that we required. We required to stop the triggers, start the triggers at the end. So there were some pre-deployment scripts and post-deployment scripts that you had to add in before you could do the ARM deployment. And now we got rid of that using the NPM package as well. So you can simply do an ARM, add, and configure your Azure Resource Manager connections. There you go. And I put my region as well. And then we need to select the ARM template that gets generated as part of the build. And it's right here. So we need to select the ARM template as well as the parameters file. Parameters file is very important, especially when you are deploying it across environments. You might want to parameterize, for example, the factory name or certain parameters and variables, link service names and stuff like that. All those references you might want to parameterize, and hence we add that as well. And for the CI into my dev, I don't need to override, for example, the factory name. But when I do the same step for deploying it into production, I'm going to probably override the factory name as well over here. So here we go. We click on save, click on OK. Just give it a name, CI. And that's about it. So this is how simply you can set it up. We can validate this. We can quickly go back to our factory. And here's my main branch. I would go ahead and create a new branch for myself, and where I will probably work. We already have 3 pipelines. I'm just going to add a simple dummy pipeline just for the demonstration and call it pipeline 4. And now we'll save this. And this is getting saved into my branch. So it will not trigger any build. It will not trigger any deployments. It will trigger only the deployments when I do a pull request, and then go ahead and merge this into my main branch. And then the whole process will kick in. So let me do that. Okay, so while the whole process takes over, I would quickly come here and validate. This is the branch, and let's go back to my dev live mode. For this is the CI which we were talking about. We actually did a CI and said we will deploy the 4th pipeline. You see the 4th pipeline 4 doesn't exist as of now because we just kicked in the CI. And let's go back and check what's the status. It's still building. It just triggered a run. releases, we can track the status. It's going to show up once it completes the build, and then the CI will get triggered accordingly. So we can hold on for a few quick seconds. Here's a release to dev. It's queued. And in this whole process, we never clicked on publish in the ADF UI. So from the ADF world, or even if there's a code-based data engineer who's actually checking in codes rather than using the visual UI, now does not need to click on that publish button. It's just going to go ahead and deploy this, and you can quickly validate it in your factory. Now, once the deployment is complete, we will hit this refresh button, and you will see those pipelines in here. So we'll just take a few more seconds. Almost done.
If I may, how recent, kind of from a historical context perspective, is the introduction of CI/CD into the world of data and data factories and data flows?
It's very recent. I think the Git initial implementation started a couple of years back, but these changes, where we actually went ahead and made the changes and made it really continuous and automated, these changes were checked in just few months back.
Wow,
this year
okay.
itself.
So this is really quite an innovation in this space, and something that people who are moving data around just aren't used to. But once they start getting used to this, the capabilities it's going to give them is going to be huge.
Absolutely. And here's our pipeline 4, which we just did, and it was continuously integrated into this environment.
Look at
using
that.
the release pipeline.
Fantastic. So many things happening in the space and so quickly.
Yep. So yeah, just to quickly summarize the things that we saw, Git certainly helps us with collaboration. It helps us save our work while data engineers work on their pipelines for days and weeks. And then it gives you better user experience in terms of loading the UI in a better fashion, quicker. And then it gives you more flexibility and freedom of deploying pipelines and doing a QA testing from a particular branch as well, using the release pipelines and the NPM package.
Fantastic. Cool. Well, thank you so much. So, Hyong, what have we seen here? But give us the what just happened over the last almost an hour from demo 1 through 3.
Sure. So one of the things that you saw, right, was we started off with the data integration and data governance coming together, right? And Linda showed a glimpse, of what are the kind of possibilities, right? Whether it's trying to figure out ETL lineage, trying to do impact analysis, or even root cause analysis on what went wrong with that report that you're trying to read today. It's all coming together with the Azure Data Factory and Azure Purview integration, right? So we started off with that, which is really exciting. And over the next few months, this is going to continue to get better, which is amazing. Now, the second part that you saw was really data flow, right? And data flow was really that notion of code-free data integration at serverless scale. And Mark showed, the ability to be able to run all this data flow where you simply drag and drop your intent, but then it runs on Azure integration runtime. Now, with that Azure integration runtime, there's often a cost to spin up the underlying Spark clusters. And what used to take minutes is now seconds. And so towards the last part of Mark's demo, you saw that now the data flow, you spend more time on doing the actual computation and transformation, if you will, without worrying about the infrastructure, right? Super powerful. And then we ended off with data ops. And one key aspect of data ops is your data pipelines, right? From, us being able to connect to Git repository, which in some of the earlier Data Factory videos or even Azure Friday shows, we showed that some time back. But what is more recent is this ability to do this end-to-end without you clicking the publish button. And that went GA in February this year, and we're so excited to share this with the community.
Fantastic. There is so much stuff happening in the Azure Data Factory space. I want to encourage folks that are watching this episode to go back and look at the huge library of great Azure Data Factory shows that we have done before. There's a great documentation, a great community around it, and a whole group of coders and product managers and program managers like the ones you've met today that are interested in your feedback. So make sure that you are giving feedback inside of the portal. It all goes to real people, and the innovation just continues. I am learning all about Azure Data Factory product innovation today on Azure Friday. And I thank Wee Hyong, Linda, Mark, and Abhishek for their time today.
Thank you, Scott.
Hey, thanks for watching this episode of Azure Friday. Now I need you to like it, comment on it, tell your friends, retweet it. Watch more Azure Friday.